Hello everyone, welcome back to our channel. Today we will be solving the tree question that is there in line 75 SD sheet. The name of the problem is finding the maximum depth of a binary tree. Okay, let's quickly go to the problem statement. We have been given the root of a binary tree. Root is the starting point basically. If anyone doesn't know it, I will point it out here. This is the root. So if we have been given the root of a binary tree, our task is to return the maximum depth of a binary tree. Depth means basically, if we consider in simple language, if we see the example, maximum depth, basically the maximum level of a binary tree. This is the first level, this is the second level, and this is the third level. So we can say maximum level of this binary tree will be 3. So answer will be 3. And depth is basically this only. We can travel how much distance we can travel from root to last node, that is leaf node. So the maximum depth means the number of nodes along the longest path from the root node down to the farthest leaf node. So we can consider the constraint as number of nodes should be greater than equal to 0, less than equal to 10 to the power 4, and node value should be greater than equal to minus 100, less than equal to 100. And I would tell the optimal approach straight away, like we have to use the recursive DFS. An optimal way to solve this problem is using recursion with DFS. Firstly, we will basically traverse the tree and compute the maximum depth of a left subtree and maximum depth of a right subtree. Then we will take out the maximum of it and we will increment 1 because we are not counting the current node, but with this to be considered at the last. Okay, so basically answer will be 1 plus max of we can say max of left comma right subtree. Okay, I will show you in code, don't worry about it. Basically algorithm is simple. This is the base case, basically if root is null, we will straight away return 0, and we have to recursively calculate the depth of left subtree, then we have to calculate the depth of right subtree, then we need to calculate the maximum of these two, then we have to add 1 for the current node because we are not taking consideration in these two. We have to add that the current node. Let's quickly look the code. Basically this is the code. So this is the max depth function. Base case is if root is equals to null pointer, we have to return 0. Then the recursive function, that is finding the depth of our left and right subtrees. This is the max, basically int left depth, and max depth root, we are inserting the root in, that is left, passing the left, and right for maximum. Then we are returning the 1 plus maximum of left depth comma right depth. This will give us the correct solution for the desired result we will get. And apart from that, if I talk about this code and this one, basically the time and space complexity for this code is since the each node is visited once, so the time complexity is O of n, where n is the number of nodes, and space complexity will be O of h, where h is the height of the tree. Worst case is basically if we encounter the skewed tree, that is if tree is like a linked list, then it will be O of n. Best case will be balanced tree, then the complexity will be O of log n. I hope the solution is clear to everyone. If you guys understood the solution, please hit the like button and also share this video with other students as well. Thank you.